Hello students, in this video we are going to study about the introduction, isomerism and nomenclature of another hydrocarbon, that is alkynes. We already discussed about alkanes and alkenes, so let us discuss the introduction part of alkynes. We need to discuss the following points here. The first point that we have already discussed about unsaturated hydrocarbons. The hydrocarbons which having multiple bonds are called as unsaturated hydrocarbon. So alkynes is also an unsaturated hydrocarbon like alkenes because there is a multiple bond between the carbon, that is, in the case of alkyne it contain at least one triple bond, that you can see it have a triple bond between the carbon atoms. So this is an example of an alkyne in which a triple bond is present between the two carbon atoms, that as it is shown here. The general formula for alkyne, that is CnH2n minus 2. CnH2n minus 2, where n is the number of carbon atom and what will be the number of hydrogen? That will be 2n minus 2. So the first member of this family is ethyne. So let us take the series of alkynes. The first member is ethyne, that is 2 carbon alkyne is ethyne. Next 3 carbon propyne, butane, and the 5 carbon is the pentyne. So here we are using the suffix YNE for representing the alkynes, that you can see ethyne, ETHYNE, ethyne. So like this the name comes, and when you look at the structure which is given here, it have a triple bond between the carbon. So at least one triple bond should be there in order to be an alkyne. And when we look at the formula, that is the molecular formula, that is for ethyne, that is C2H2. When you apply the formula, that is CnH2n minus 2, this is the general formula. So when n is equal to 2, so what will be the number of carbon here? That is C2, and number of hydrogen will be 2n minus 2, that is 2 into 2, 4 minus 2, that is 2. So C2H2 is the molecular formula for ethyne. And the first member of this family, that is ethyne, which is also called as acetylene. Now let us discuss the structure of alkyne. We already done the hybridization of ethyne in the chapter chemical bonding and molecular structure, where we have discussed that here the carbon is sp hybridized. So each carbon atom of ethyne has 2 sp hybrid orbital. From this, one of the hybrid orbital overlap with the 1s orbital of hydrogen to form a sigma bond, and the other one is overlapping with the sp hybrid orbital of other carbon atom to form sigma bond. So here there is a formation of sigma bond, that is due to the head-to-head overlapping, that you can see here. Here there is head-to-head overlapping between the sp hybrid orbital of carbon with 1s orbital of hydrogen, and here also there is a head-to-head overlapping between the sp hybrid orbitals of 2 carbon. This is about the sigma bonding, it is shown here. Here also pi bonding is also there, that is the 2 unhybridized orbital of the carbon, that is overlapping with the unhybridized orbital of the other carbon. So here there is a sidewise overlapping, as we have learned there is a sidewise overlapping, so there is a formation of pi bond. So here the 2 pi bonds are formed, which is shown here. So that is we can say that the overall structure when we make we can say that the carbon is bonded by triple bond. From this, one of the bond is sigma and the other 2 bonds are pi bond. and this carbon is forming a sigma bond with the hydrogen, that is due to the head-to-head overlapping of sp hybrid orbital of carbon with the 1s orbital of hydrogen. So this is what the structure of alkyne, that is we have taken the example of ethyne, that is the simplest molecule of alkyne series. When we talk about the isomerization, we have already discussed the definition for isomerization. When we take some examples which is given here, the example like pent 1 ion, pent 2 ion and 3-methyl but 1 ion. So when you look at here, in all these the molecular formula is same because the number of carbon atom and hydrogen is same. So these are actually, we can say that these are the isomers. And when you look at here, the first and second isomer, in this there is a difference in the position of triple bond. So the first and second structures are the position isomers because here the number of carbon in the main chain is same. That is, you can see in both the cases there are 5 number of carbon in the main chain. But what is the difference? The difference is the position of triple bond, that you can see here. The triple bond in the first structure, that is in between the first and second carbon there is a triple bond. But in the case of second structure, triple bond is between the second and third carbon. So there is a difference in the position of a triple bond. Therefore, this is called as position isomers. And when you look at the third structure, in the third structure, the triple bond is between the first and second carbon. But what is the difference? Here the difference is the number of carbon atom in the main chain. So when you look at the third structure and when you compare with first and second, you can see that in the first and second structure, the number of carbon atom in the main chain is 5. That's why the word root is coming here 5. And what is the word root in third structure? That is but, because the number of carbon atom in the main chain is 4. So here there is a difference in the number of carbon atom in the main chain. Therefore, we can say that isomers are called as chain isomers. So we can say that first and third structure is a chain isomer, or we can say second and third are the chain isomers. Here, next we are going to discuss the nomenclature. So better we'll take some examples and we'll be writing the name for this one. We have to follow the same rules because here there is only carbon and hydrogen. There is no another functional group here. So triple bond is given, that is between the first and second carbon. So here we have to give importance to the triple bond because there is no functional group and there is no other substitutes are there. So we have to start the counting from this carbon. So 1, 2, 3, 4, 5, 6. So 6 carbon atom are in the main chain. Therefore we use the word root hex. Here there is no substitute, therefore prefix is not used, and the position of triple bond should be mentioned, that is 1, and we are using the suffix for that is primary suffix YNE. That is, if there is a triple bond, we have to use the suffix YNE, that is the position it is on the first carbon. When we look at the second structure, in the second structure the number of carbon atom is same as it is, that is 6. But what is the difference? The difference is between the position of triple bond, that is between the second and third, because this is the first one, this is second, third, 4, 5, 6. So here the triple bond is between second and third. So we have to name it as hex 2 YNE, hex 2 YNE, because here the triple bond is between the second and third. So we have to use the number 2 here. The next structure, when you look at here there is one prefix. So first of all select the longest chain. This is the longest chain, and where is the substitute? This one is a substitute. So we have to use the prefix also. Now from where we have to start the counting, because here substitute is there and also triple bond is there. So we have to start the counting from by giving the preference to triple bond. So we have to start the counting from here. So this one will be second carbon, third, fourth, fifth. So now here when you look at here, the prefix we are using here, that is for substitute, that is on the fourth position. So that is what it is given as name as 4-methyl. Methyl is the substitute at the fourth position and the number of carbon in the main chain is 5. That's why we are used the word root pent, and triple bond is on the first and second, therefore 1-YNE. This is the name for this compound. The next structure, now here also you need to select the longest chain. So when you select the longest chain, this one will be the longest chain, and we have to start the counting by giving the preference to triple bond. So this is the first carbon, this is second, third and fourth. So here the two substitute we have here, that is the substitute methyl group are the two substitute. So the position of the substitute is on the third carbon, therefore 3,3-dimethyl, and the word root is but, 1-INE, because triple bond is between the first and second. So this is actually when we compare these all structures, in all these structures the number of carbon and hydrogen is same. So that is actually, this is actually based on the problem number 13.13, which is a text solved problem. Write the structures of different isomers corresponding to the fifth member of alkyne series. Also write the IUPAC name of the isomers. What type of isomerism is exhibited by the different pairs of isomers. So now which one is the fifth member in the alkyne series? The first member is ethine. First member is ethine. Second member is propyne. So like this, when you count it, third member is butane. Fourth member is pentane. And the fifth member is hexane. So the molecular formula C6H10, that is actually the molecular formula for the fifth member of alkyne series. Bond is between first and second. In the second structure, it is between the second and third. So here it is in between the third and fourth carbon, therefore hex 3-YNE. So make the position, just change the position of triple bond and make the possible structure. So these A, B, C, these are the actually position isomer. Even we can branch the carbon chains. Like if we branch it, we will be getting D structure, C structure, and even F and G. So these are actually all are the isomers because they have same molecular formula but different position of triple bond or the different number of carbon in the main chain. So these are the structures of isomers, possible isomers of the fifth member of alkyne series.